This presentation is about event bus design patterns by Kobe Campbell and Adam Tipton. Hi, I'm Adam Tipton.
And I'm Kobe Campbell.
The event bus pattern allows messages and data to be quickly transmitted through a pipeline of connected devices who will intelligently process the data. Event bus is a primary part of the event-driven architecture. We'll briefly discuss event-driven architecture before delving deeper into what an event bus is and how it can be best utilized. Event-driven architecture has the ability to detect events, which are changes in state, and interact intelligently to them. You may not realize it, but EDA is all around us. For example, imagine a sensor that reacts to the change in state of ambient light to either turn on or turn off a safety light. Or perhaps a traffic sensor that determines if the vehicle occupies the intersection or not and changes the traffic lights accordingly. An EDA design will generally include event producers who create the events, event consumers who have a vested interest in the event, a messaging backbone to distribute messages to all consumers, and an event manager of some sort to handle all the events. As part of the EDA, the event bus pattern allows events to be passed through a pipeline to consumers who have subscribed to certain events. After the event is created, it is then sent through the entire pipeline to all consumers. It is the responsibility of the consumer to decide if it wants the event and then what to do with it. For example, a widget message event is created. The appropriate event manager sends it to the pipeline for distribution to all consumers regardless of the subscription or interest. Once the consumer receives the widget message, it determines if it is subscribed to that particular event manager. If it is, it intelligently processes the event. Otherwise, it just skips over it. At its basic level, an event is a change of state, which is transmitted through the pipeline as a package of data or message. It is the data to be communicated. Back to our previous examples, if the light sensor detects a change of state in the ambient light level, it creates an event and sends it through the pipeline. So what is a pipeline or a bus? A pipeline is not dissimilar to any interstate freeway, except that the vehicles are required to visit each and every off-ramp. For our purposes, the asphalt of the freeway is the pipeline. The cars are the event messages, and the off-ramps are the connections to the consumers. Event traffic flows from the event source to each and every consumer connected to the pipeline. In simple terms, the pipeline is the delivery system for events. One final note of the pipeline. Just as a freeway doesn't care if there are cities connected to it or not, the pipeline does not care if the event is received by the client. Consumers are computers and devices that are connected to the pipeline who have a vested interest in receiving certain events. Clients subscribe to certain types of events through an event manager. Clients will receive every event that flows down the pipeline, whether they're subscribed to it or not. Once a client detects an event, it first determines if it is interested in it or not through its subscription status. If it is subscribed to that particular event, it will receive and intelligently process the event. We've mentioned the concept of subscription several times now, but what is a subscription? What does it mean to be subscribed? For our purposes, a subscription is an agreement between the consumer and the event manager to receive events. For example, a consumer will flag events from a certain event manager as being subscribed to. Once those flag events reach the subscriber, it is intelligently processed. Simply, a subscription is a method to filter unwanted events. In most cases, there will likely be a need for event management of some sort, either through a third-party manager like Guava.dev or a custom-designed class. An event manager will receive events from event creators for processing. Once the manager logically processes the event, for example, tags it with metadata, so subscribed consumers will recognize it, then it sends it to the pipeline for distribution and eventual consumption or skipping. Although it may seem redundant to have an event creator and an event manager, Why can't event creators send them themselves? We must understand that event creators can also be event consumers. Therefore, it may be more prudent to implement an event managing class so that the event manager objects can be created. A centralized class will help to reduce duplicate code and make implementing the event bus simpler. Proper event management is key to the success of the design. The Food for All app is a group-oriented app. It could greatly benefit from event bus implementation. Event creators, for example, someone who has created a meal plan, can quickly pass their data along the pipeline for quick consumption. The following slides will illustrate one possible way that an event bus could be beneficial to the Food for All app. For simplicity's sake, we will exclude the event manager, which is not shown, but implied. Shown are 6 consumers connected to a central pipeline. Some consumers are currently subscribed to Group A, while others are subscribed to Group B. A new meal plan event is created with Group A metadata attached and then connected to the pipeline for distribution. The pipeline detects the incoming meal plan event and prepares to distribute it. The pipeline has now accepted the new meal plan event and begins distributing it to all consumers regardless of the connection or subscription. The new meal plan event is offered to each consumer. Consumers that are subscribed to Group A events accept the new event and begin intelligently processing the data. Consumers that are subscribed to Group B skip the event. No data is accepted. With the distribution of the event complete, the new meal plan event is cleared and the consumers revert back to a waiting state. The cycle restarts with a new recipe event with Group B metadata connecting to the pipeline. As a result of the event bus and the implementation of subscriptions, only consumers that were subscribed to Group A gained access to the new meal plan. Group B, on the other hand, which was not subscribed, skipped the content.
Some of the benefits of using event-driven architecture include its reusability that allows implementation across numerous different networks. It accomplishes this by being structured with loosely coupled functions that are designed for easy implementation into complex engineering systems that won't need to be formally defined with autonomous coupling and decoupling across multiple networks for multiple events. Another benefactor when using an event-driven architecture is that they can be highly versatile and, when implemented correctly, can adapt to overcome many different situations that may arise when executing the event. Event-driven architectures are inherently designed to process and handle chaotic and random behavior in most environments that they're implemented in. Now, event-driven architecture is designed for optimization of instantaneous data analysis and response before any critical event is executed. Overall, event-driven architecture allows for design of application to be responsive and adaptive. This allows for the events to be responsive across multiple platforms. Due to the fact that event-driven architectures are designed to be loosely coupled and massively distributed, it is often hard to predict the behavior of all the possible implementations, malicious or benign, that may be delivered through the event bus. This can cause sporadic and chain reactions that is set off by some unseen trigger that could be either accidentally fired or sent by an attacker exploiting the bug. Another disadvantage to using event-driven architectures are that due to the versatility and distribution methods, the system can easily become overcomplicated, and this comes with the architecture's open and non-linear design. Thank you so much. This has been our presentation from Adam Tipton and Kobe Campbell on event-driven architecture. Thank you very much.